In this video, I will talk about a sample from previous published study for this one, and for which I was responsible for XPS analysis, but I was not available and another group made the XPS analysis. This is the paper. So binder coated carbon cloth electrodes for aluminum vanadium redox low batteries. And the paper uses carbon fabric electrodes. So this is the sample. You can see the images, microscope images of the sample. And this is nearly all of we know about, since the electrode or the carbon fabric is produced by a company, and company keep the properties of the sample as a secret. And I have a data for the 48-hour activated fabric sample. And the research group provided me with a carbon fabric sample and mentioned that it contained organic binders. The sample is highly conductive, so it is a electrode. Therefore, we don't expect any charging issues during the XPS measurements. By the way, although published paper does not include an XPS peak fitting, actually I couldn't find it in extra documents, so there is no XPS fitting in this paper. I have the original data for the carbon 1s spectrum of the 48-hour activated sample, and I will open this data in CasaXPS and perform a basic fitting. So this is the all we know about the XPS fitting, XPS sample, sorry. And basically we know that sample is a fabric carbon or carbon fabric, and there are organic binders on it, and it has a dark gray color. By the way, the sample was gray, dark gray, and we expect to observe ketone, ester, and alcohol groups due to the binders, since the binders are organic molecule. And activated means is that it is heated at 300 Celsius for 48 hours. So this is what we know about the sample. So I will open the data file, convert, and activated sample 48 hours. So this is our sample. As you see, in the carbon 1s spectrum, there is a clear pi to pi star transition about here. So which indicates the presence of graphitic or graphene-like carbon structures. And I want to look at a similar paper which use a carbon electrode, and I simply found this paper. This is an old paper, but they uses graphite electrode materials for the lithium ion batteries, and you can get the paper. And the same group, or this paper, you can find the peak fitting. So as you see, there's a graphite hydrocarbons fit for the organic groups here, and there is also pi to pi star transition. So our sample should be very similar to this one. So I assume that it is very similar. Of course, the concentration of the groups are different, probably. Most probably it is different. And I want to make this kind of peak fitting for our sample. And by the way, which background should we use? And therefore, I want to show you another resource here. This is the third paper. Firstly, we can use the Shirley background for the carbon 1s peak fitting. And Shirley backgrounds are not suitable if the sample is insulating material. But this is not the case. Our sample is an electrode and it is very conductive. We should see a pi-to-pi start transition or the shake up peaks, and we saw it clearly. There is a pi-to-pi start transitions in our data. And by the way, we can use a Shirley background according to this paper. And I will do that. Firstly, I want to add a background. So regions create not to guard. I want to use Shirley. Okay. And I will hit enter. So this is our background, but I have to adjust the positions. And this is our background. And I will put my components or peaks here. Firstly, clearly we have graphitic carbon. So the first one, graphitic. So I think we can use the GR30 or 40. I will use 40. It is more familiar for me. And the graphitic carbon, we can look at our previous data. So it has around 1.5 full width half maximum value. So maybe I should use, I can constrain it until 3, and position should be around 284. So it is good enough, I think. Yes. So this is our first peak. And I will also add an aliphatic peak. This should be an aliphatic peak. And it should be around 285, but I will write the name. Aliphatic. And full width half maximum can be higher for this peak. As you see, it is higher. This is our aliphatic or hydrocarbons. Maybe it should be around 2.5, and we can constrain it until 3. I want to constrain the position to 84.5 maybe, and this should be something like uh, 1 second. I should write the bigger value first, and to 8 should be 4.8. So 284.8 to 285.3. Okay, it should be between here and I want to constrain the first one, so to 84.2 to the 2, 1 second, 283.82 to 84.2, and I will make the other peaks. So we should have organic molecules peaks or this kind of groups. So I will create one more. This is for carbon, oxygen, carbon bond, or carbon, oxygen double bond. I will again use GI40. Full width half maximum. This is also a broad peak. As you see, it's pretty broad, maybe more than 2. So I don't know. Maybe it should be around 2 or 2.5. And constraint can be between 0 to 3.1. I think this should be good enough. And the position should be around 286, maybe 0.5. Of course, the intensity should be a bit low, maybe more than around 400. And I want to constrain the position to 87.82 to 88.5. And maybe we have a mistake here. Yes. Okay, I will put another peak. It should be around here. And this is for the ester groups. For carbon, no, oxygen double bond, carbon, oxygen. So this is our ester group. Again, I will use GI40. And full width half maximum, I think should be less than 3. Or it should be between 0 to 3. And position should be about 288.2. So I am considering this one. So it's here, maybe 288.5. And the area is, I think, smaller for us, 300. And we have a pi to pi start transition, which should be around here. So I will create one more. And this is for pi to pi start transition. And this is the GL30 or 40, GL40 is fine. And full width half maximum, maybe should be around 2. So the peak is actually here. and this is, I think, more reasonable, but this peak might be bigger. So I will constrain the position. So this is our position constraint. 292,288. So these are the our peaks. So maybe I should write this constraint again for the star group 2912289. So position says wrong, and it is right. Maybe I should 289. 289. 289 to 290. Okay, and I think we can fit the components. I will constrain the region, okay, and I will hit fit. So I think it is a pretty good fit. So we have a pi to pi transition here, ester group here, carbon oxygen carbon or ketone group, and aldehyde groups are here. So we have a aliphatic peak here, and we have a graphitic peak here. And this is the case, and I can also look at the data, the other sample. So I think it seems good enough, and this is the our peak fitting. By the way, positions, maybe we should check the positions again. There should be little, maybe their sample has little bit charging. Of course, it is also another thing to consider, but it's also an electrode. But this is what it is, and I think this thing is good enough to make a publication. By the way, and you can find the papers in the description, and if you have questions or comments you can write them. By the way, this kind of fitting is completely open to discussion since we don't know nearly anything about the sample. I basically understood it has a polymeric structure due to the pi to pi transition. So this is the only thing. Without this information, would be completely wrong. So this is the our key points in here, pi to pi transition. And thank you for your attention.